We're continuing our discussion in land investments. Now, I'm going to introduce something in real growth that could be done for any capital budgeting problem, but I'm introducing it into the application of land. But it's important to understand that this same concept of real growth could have been used in your center pivot irrigation problems. Just that I'm starting to add little pieces as we go along. In this particular case, the real net returns of $40 per acre are assumed to increase by 2% each year, where before we assumed that the real returns were constant. Now we're assuming that because of some technological change or some other factors, maybe because of the increased demand for U.S. agricultural products overseas, for whatever reason, we believe that there's actually going to be a relative change in our value and returns to land. And we believe because of that, as we're projecting that we're going to continue to have a 2% increase in the real value of returns to land. We also believe the real price of land is actually going to increase 6% a year. 2% for the net returns to land, 6% in the actual land values. That may simply be because of urban encroachment. As because of its close proximity to urban area, we think that those land values are going to go up even greater than the rate of increase of its profit. We also expect that inflation will be 5%. Everything else is the same as that we just went through for the land investment that is stated in your handout. To handle this, we're going to first calculate the real net returns that are going to be increasing. They're not constant now, so we have to do some computations. Second, we're going to calculate the nominal net returns, which is something that you've been working on. So the first step is to calculate the real net returns. Again, we're going through a sequential process. We have to solve this piece before we can solve the nominal. We have to know the nominal before we can do the after-tax nominal value. That has to be known before we can find its present value. Again, you have to go through sequential steps. In this particular case, we're going to use a similar type of equation that we've used before, but the symbol and the purpose changes. In this case, we're going to let this lowercase g represent the real growth rate. We're going to let this F star represent the real value at time 0, and the Fn represent the real value in the nth period. So we see that the real value is growing from F0 to Fn, where I used the star superscripted to represent that those variables are real. So in the first period, we said, using today as our basis, the real net returns of $40 is going to increase at 2% per year. So we're going to compound that at 2% for one period, and it's $40.80. That becomes our real net returns at the end of the first year. For the second period, we're taking the real value today, we're compounding at 2% to accommodate for the real growth, again for 2 periods, and it comes out to $41.62. And in the third year, we do the same, only in this case it's compounded for 3 periods for $42.45. Now, if you look at these 3 numbers, those are the real net returns in the first, second, and third years, respectively. And we're going to take those now and put them into our chart that we've been using. Notice that this real net return in the past were constant. When we did the land before, those were $40. They were constant in each of the first, second, and third periods. Now, because we've assumed that there's a 2% growth, each of those have increased. After that, however, we treat those the same way as we did before to convert the real to nominal, meaning that we take the real value in the first period, we compound it at 5% for one period. That number we take and we multiply it by 1 minus the tax rate to get the the after-tax nominal value. And notice that process also happens in the second period, compounding it for 5% for 2 periods, multiplying it by 1 minus the tax rate, then also to get the after-tax nominal net return. And we do that for the third period as well. The only thing different is that we are sequentially calculating its real return before we go to the nominal. Again, notice these three numbers in this chart. Those are the after-tax nominal net return. Those are our cash flows that we're going to use in our net present value worksheet. And sure enough, we've transposed those numbers and put them in this component. We said we're going to hold everything else constant, so notice that the initial cost is $5,000 per acre. Again, we're assuming no structures on this land, so we can skip the depreciation. Now let's talk about the price of land. We've assumed that the real price of land increases at 6% each year. The farmer plans on selling the land in 3 years, so we first need to calculate the real expected land price in 3 years. And then, once we know the real price, then we can calculate the nominal expected land price. And then once we know that, then we can calculate the after-tax nominal terminal value. We're going to use our formula again, where we're going to take the real price of land. We're going to compound it at its growth rate for the appropriate number of periods. In this particular case, we said that the price of land today is $500. We said its real price is going to grow at 6% per year, so we compound it for 3 periods to find its real value at the end of 3 years. We do the arithmetic, and we see that land prices in real dollars is $595.50. In terms of our apple example, if you can buy an apple per dollar, that means that he gave up 500 apples when he bought the land 3 years ago. When he sells the land in 3 years, he can take that money and buy 595 apples. There's been a real increase in his wealth per acre of 95 apples. So we calculate the nominal terminal value, which means how much does he actually receive from the sale of that land. Notice this equation is different. In this particular case, we're taking the real value, you see the star, in the nth period, and we're going to convert that real amount in the nth period to its nominal value by compounding it at the rate of inflation for the n periods. Notice in this case there's no star because that's representing the nominal price of land. You have to pay attention to those symbols because they look the same, but they represent different things based on the rate. So in this particular case, we calculated the real price of land at $595.5. We're going to compound that at the rate of inflation for the 3 periods to come up with the actual nominal value. And it turns out to be $689.37. What this says, that the farmer paid $500 for that land. At the end of 3 years, he's going to sell it for $689.37. A sizable increase. We're saying part of that came from the real increase, and part of it came because of inflationary factors in the economy. But even though this farmer receives $689, his real wealth is only increased by 85, not the 189 that you see here, because part of that was inflationary, but part of it was real. Now we plug this into our after-tax terminal value formula, again because we assumed there were no structures or depreciable structures or items on this land. We can simplify this equation by getting rid of the cost minus the depreciation. In this particular case, we're selling the land for $689.37. We purchased it for $500, so you see that there's a taxable gain. Part of that is a real gain. Part of that is inflationary. So you have a combination of being taxed on real growth and wealth, and you're also having an inflationary tax. And our after-tax terminal value then becomes $660.96. After the farmer pays Uncle Sam the gain on that land, $660 is what remains. So we put that into our spreadsheet. Then we calculate, as we did before, the present value of each of the components. We sum them up, and we see in this particular case with the real growth in returns and the real growth in land values, that you see that the net present value of that land is increased to $116.87. Approximately how much under this new environment could an individual pay for that land and still break even? $616, approximately. I won't cut it in the exam, but just in a quick look. So you see that, for example, in an environment now, even here, looking at it from rental properties in this city right now, there's been a growth, an increase in house prices and in rental prices. And that gets factored into what people are willing to pay. The bid price of these rental properties, investment properties, has gone up. At the same time, what happens if the expectations change and people think that real growth is going to stop? What's going to happen then to the value? It can go down.